Hi everyone, welcome back to my channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So as you know, we were following our pattern wise DSA sheet, and in this we were doing stacks topic. Following first pattern, which is monotonic stack, today we'll do next question, which is online stock span. So let's read the problem statement. It says the stock span problem is financial problem where we have a series of daily prices quotes for a stock and we need to calculate the span of stock prices for all days. Okay, so you are given an array as shown and representing daily stock prices. So first index value means 100 price, second 80, 90 and 120 for ith day, and we have to return the span of stock prices for each day in the given sequence such that for each the price of stock is less than or equal to the price on day I. So as you can see on 100 day, okay, so towards its left, how many such numbers are there which are less than or equal to 100? So if you see 100 itself is equal to 100, so for 100, one element. For 80 if you see towards the left side, then 100 is greater, but 80 itself is equal to, and we have to calculate all such numbers which are less than or equal to 80. So definitely 1 for 80. Now for 90 itself and 80. Okay, so basically, don't you think we are actually finding the next greater element only? So let's see the constraint here. Constraint says array size can go till 10 power 5, but why we read so? Because it will tell us ki our brute force code will give us TLE or not, and how we can optimize it further. So let's come on to screen. Here is the array has been given, and for 100 we don't have any such element, so 100 itself we will count. Okay, so forget about the optimized approach, just think for the brute force approach. Key for 100 itself we will count. Okay, for 80 we have to look towards its left side. So don't you think if we'll start our I, okay, from 0 index, and j also we want to start from the 0 index itself. Why? Because we have to look for every element which is less than equal to. So for equal to, though, we should start our j from the ith itself, right? Yes. Now what we do, if it is less than equal to, yes, and then we move our j towards its left side. But now as j is out of index, so for ith index we will add one such count. Okay, now we will initialize our I from first index. Again j from first index is 80 less than equal to, definitely. Now we will move towards its left. So now we say ki is 100 less than equal to, no it's not, so we will stop and we will count what? If you see from j to I, how we calculate the length, if you know. So when my j was here, obviously it satisfies the condition, so we will do the count for this. But when we move our j behind, this was not less than equal to, hence we will break it. So in this, for this I is equal to first index, only one such count, so again we will put 1. Now we have to reinitialize our ij, so when I will come here and j will also come here. Now again this satisfies yes. Now here also this condition satisfies yes, so we'll count 1, and now we'll move this j towards left. And as we can see, yes, 80 also satisfies ki yes it is less than, so again count plus plus means now count 2. Again we will move this j towards its left, and now the condition fails because 100 is not less than 90. So till now count is 2. So for jth index, for ith index we will put 2. Now again we have to reinitialize, yes, our I and j. Here obviously this satisfies the condition. 120 is less than equal to, count 1. 90 is less than equal to, count 2. 80 is less than equal to, count 3. 100 is less than equal to, count 4. So hence for I is equal to 3, we have to write count 4, and this we have to return. Okay, so obviously we can write the code using 2 for loops, but if you see here, for every ith index we are starting our j from the same index and going towards its left side until it hits the negative -1 index, correct? So can I say for every I we want the j to run from the same ith index to 0. So don't you think it's n square? Yes. And if n is 10 power 5, n square code will be 10 power 10. And beyond 10 power 8 gives us TLE. And to be more precise, if your code is more than 10 power 9 or 8 into 10 power 8, something like that, we can for sure say ki it will give us TLE. Okay, so how I calculated? Depending on the logics we have written, till 10 power 8 our code is safe. okay, if the logic is simple. But beyond that, 4 into 10 power 8 and all, it will be slow. But 5 into 10 power 8, sometimes 6, and 10 power 9 to for sure will give us TLE. So till 10 power 8 we can think it will be slow. But if the code logic is very complex, sometimes we even get the TLE at 10 power 7 as well. So simply you can think of, if any code goes beyond 10 power 8, you can think it will give us TLE, and we have to optimize it. But let's see the brute force code here. This is what we discussed. First we will calculate the array length, and we will initialize the array list for name span, where we'll save our answer. Now we'll run the for loop from 0 to n, and for every I we want our j loop to run from I to 0. Okay, so you can think of both the cases. How? If you will run from, you can even run from I also, the condition will vary. Here suppose we are running from I minus 1, because we know when our j will be equal to I, definitely our that count will be 1. So that's what we did. If we are starting from I minus 1, we initialize our count from 1. If we want to start from I, we will initialize our count with 0. I hope this is clear. Okay, and we'll see if our any array of j, means towards the left element, if it is less than equal to, we will keep on counting our incrementing our count plus plus. Else, whenever the condition does not satisfy, we will break the for loop, we will come out of it, and in our array list span we will add that count value. After coming outside both the for loops, we will return the span, but the time complexity will be O of n square. So hence when we will submit this code, this will give us TLE for sure, as expected TLE. Okay, so how we can optimize it? If you know, we already discussed कि whenever we are looking towards left side or right side, just to get the greater element or smaller element, we always use stack data structure there, correct? So here also we will use stack data structure, and if you see, this is nothing but next greater elements towards its left side. Okay, so on a safer side, it's better to start our iterating our ith value from 0th index instead of last index. Okay, again saying we can do in both the directions, but the element where we want to put our answer, if it's about left, next greater element towards left, so always start from ith index, because the ith index you can save in our answer value. But if you start from the opposite direction, then you have to keep the elements in the answer not as per ith index, but as per stack.peak value. This point, whatever I said, we have already discussed in our previous video. If you have not watched that basic standard problems of next greater element 1 and 2 from LeetCode and GFT, which we already did, then it would be difficult to analyze what line I said. But if you know this, it's good to go. So as it's next greater element towards left, so we would like to start our for loop from 0 index. Okay, I will be 0. Now what I am saying, every element we will keeping in stack. So let's make a stack and let's keep this 100. But when we are at 100, our stack is empty. So whenever our stack is empty, what do you think? For every element, what should be the answer? As you know from output 1, correct? So can I say even the stack is empty or not? See, here stack is empty, answer is 1. Here stack is not empty, means when I will be at 80, obviously 100 will be there in the stack. But 100 is not smaller than it, correct? So hence 100 is not a valid answer. So for 80 also our answer is 1. So can I say, if for any element stack is empty, or else for any element we have not found any such element towards its left side which is smaller, answer is 1. So I can do one thing. What I can do, yes, if the stack is empty, we will simply put I plus 1. Okay, why I plus 1? I'll let you know. If my stack is empty, in my answer array, definitely at ith index I want to put the answer I plus 1. Okay, why it will be so, I'll prove you. And I want to run my I from 0 till I array dot length, correct, and I plus plus. Okay, now for every I will check if my stack is empty. If my stack is empty, definitely I'll put this. Okay, now I'll move my I ahead at 80, and definitely I'll add 100 in my stack. Okay, done. Now when I'll be at 80, definitely I'll check all my stack elements. So what I'll do, I'll check while my stack is not empty, to check my stack should not be empty now, and along with that, okay, can I say if 80 is there and this is 100, correct? So if suppose it's 70, so I can pop this. Why I'm saying? Because I am looking for next greater element. So if I'll be at 90, like future elements towards right side. So if I'll be at 90, suppose here a smaller number, call 60. So for 60, definitely 80 will be the greater element and not 70 anymore, correct? So we can pop this out. So what we do, we'll check if my stack is empty. Yes, like I'm trying to write the pop condition. If stack is empty, yes, and if stack dot peak means a stack dot top element, correct, is less than equal to what? Current element, which is array of I. If this condition satisfy, I would like to pop the element from my stack. Okay, I'll pop this and I'll check if my stack is empty, I'll put this, or else I can directly write else. If my stack is not empty, then in my answer of I want to put j minus I. But why j minus I? Okay, for this condition 80, obviously stack is not empty and the topmost value is not less than, so definitely will not pop anything. So for this 80, stack is not empty, yes. So for this else case will run. What is the ith index? If you see, what is the ith index? Which is 1, correct? Yes. So here I want index or I want number to get my answer, because I have to give how many such elements are there, count, can I say, and that is nothing but length. Yes. So instead of inserting the elements in the stack, we will insert the index of that. Okay. So now what we'll do, what is this? I, and what is this? This is 1, this is 0. So what do you think? How can we calculate if we will subtract this? Okay. So what we'll do, I minus stack dot peak. Yes, we'll do this. So we got 1 minus 0, which is 1. But you will think ki we to calculate length by using this j minus I plus 1 formula. Yes, we do. But only if suppose this is I and this is j. We do only when both of these elements are valid. But in this case, this element is not valid now. Means this 100 is not less than equal to 80. So when this is not valid, so what we do, j minus I plus 1 is a common formula to calculate length. And because the ith element is not valid, we subtract. So hence anyhow it's j minus I. So that's what we did, I minus stack dot peak, because this first element is here and this current element. Okay. So with this, when you come outside, you can simply return your what? Answer array. And if you see the time complexity here, it will be O of n plus in worst case O of n, because this while loop in worst case will end up popping every such element in the stack. But don't think it will be quadratic, means it's not O of n square. Why? Most of us gets confused initially by seeing this in nested order, because for loop and while loop is in nested, so this will be obviously O of n square, but it's not. Basically this while loop is doing what? It's popping every elements in the stack, and every elements are going in the stack only for one time. So in worst condition also we'll end up popping every such elements, which will take O of n time complexity and plus O of n for this. So hence it's linear solution, and this will be far better solution, an optimized one. So let's write the optimized code. First we would like to calculate the length of array, which is array dot length, correct? And then we want to calculate, like create the span, which is array list of integer type, called span is equal to new array list. Okay. Now we want to make a stack, correct? Stack of type integer. Now we want to run a for loop for int I is equal to 0, I less than n, I plus plus. Now what we want to do, we will check ki while our stack is not empty, dot is empty, yes, and what's the popping condition? Ki if my stack dot peak element, okay, if my stack dot top element is less than equal to the current element, which is array of I. If it is so, we can simply pop from our stack, correct? Yes. But if not, we'll check ki if our stack dot is empty. If our stack is empty, if you remember for 100th element, for 100, what we wanted to put in our answer variable, like span. So what we put, span dot add what? I plus 1. Okay, you will say okay, initially though it's I plus 1. We will see for last also. Now for 80, when our stack was not empty, what we did? In our span, what we put? Span dot add I minus stack dot peak. Yes, minus. Yes. Now whether are any of these if, else or while case run or not, but in every iteration we have to insert the ith index in our stack, correct? And after coming out of this for loop, we can simply return our span array as an answer, correct? So now we can run this. Okay, my bad, as we are pushing the index, so we have to read like array of stack dot peak, then only we can compare, right? Because earlier we were comparing with the index, that is wrong. So now as you can see it's running. So now we can try submitting this code and it will get submitted because the time complexity is linear, O of n plus n O of 2n basically, which is linear only. Okay, now the thing is, for the last one definitely we'll end up pushing 80 means for 1. Now when we will come here on 90, okay, we are dry running this. So when we'll come on 90, we'll see yes, for 90 80 is smaller. So we will end up, you know, erasing this, like remove this. And now for 90 definitely 100 is greater, so will not pop, and now for 90 we'll push the index. Now once 120 comes, it will pop this 90, correct? So we will pop it. Okay, now as 100 is also lesser than 120, so it will also get popped. Now in case of 120, obviously stack is empty, so for this first if case will run ki stack is empty. Now for this, if you want to calculate how many such element, so don't you think the index is 0 1 2 3 3, so definitely all such elements which are less than is 3 but equal to is 4, so hence we will add I plus 1 in this case as well. So hence it satisfies the condition, right? Okay, so this was our Java code and here is your Python code. If you guys are from Python background, all the approach is same which we discussed in the video. If you understood this, you can write on your own as well. And here is your C++ code if you guys are from C++ background. And if you understood the problem, the brute force approach and the optimized approach, like why we applied the stack data structure only, then you can definitely go in the sheet and mark the next question as done. Okay, but hoping you will not copy paste and you will submit on your own. So I hope you got this, and that's it for this video. If you have any doubt, do let me know in the comment section, and if you guys like the video, please do like the video and please do subscribe the channel if not yet subscribed. And if in case you guys are new to this channel, then we are following the pattern wise DSA sheet. You can check the link in the description, and if you want to connect with me on any social medias, all the links will be there in the description. And that's it for this video. Let's meet in another video with some more interesting questions and topics. Till then, keep learning, take care of yourself and your family too.